Welcome to MyProjectBazaar.com. Let me discuss about the project analysis of T-slot loaded disk patch antenna for dual band operation with small frequency ratio. Let me discuss about the abstract of the project. Nowadays, the communication industry field is mainly focused by high data transfer and more channel capacity in mobile communication. MIMO OFDM is the foundation for most advanced wireless local area network and mobile broadband network standards. The monopole resonator antenna is used to perform the radio frequencies and to radiate the omnidirectional pattern. This type of antenna is used to multi-broadcasting ultra-wideband antenna technology for transmitting the information through large bandwidth. Currently, highly directive antennas on the market can range from as little as $50 to a couple of hundreds of dollars. Gain of these antennas is between the ranges between 8 dBA to 20 dBA. Cheaper alternative with a similar gain characteristics can be developed to appeal to the consumers on the market. Rapid growth of wide-band communication system, the circularity polarized patch antenna plays unbeaten able place. In omnidirectional circular patch has provided large signal coverage and stability for the signal transmission. Designed antenna has low profile of complexity for WLAN wireless local area network. Our proposed work is to design a T-shaped ultra-wideband 2-square monopole antenna. This antenna design is to increase the frequency band level and to cover the notched band in 5.15 to 5.85 GHz. Proposed design is to ultra band pass filter using T-shaped monopole antenna. This design is to implement the MIMO notched antenna technique. This design is to modify the substrate integration module and to satisfy the ultra wideband frequency response process. This process is to improve the differential communication system performance level. This antenna requires low-cost, compact size. This ultra-wideband antenna used to ease the integration for devices. Antenna bandwidth is range of frequencies within which the performance of the antenna with respect to some characteristics conforms to a specified standard. Low cost and to easily integrate the other devices to reduce the overall insertion loss and return loss. Let me discuss about the flow diagram for our process. Initialize the parameter. Here the antenna parameters such as relative permittivity of the substrate, thickness of the dielectric substrate, radius of the disk patch, length of the vertical slot, length of the horizontal slot, thickness of the slots and feed locations are initialized based on the T-shaped antenna. And next, derive the antenna design equation. Here we have to derive the parallel combination of resistance, inductance and capacitance. With this equation, we have to estimate the resistant, reactive component and impedance. The resistance, that is length and width of the vertical slot and length and width of the horizontal slot, we can estimate the resistant, reactive component and impedance. Here the resistance is the represents as RXS and RXVS and reactive component is the X and impedance is the Z parameter, and these are the estimated based on the vertical and horizontal slot. Finally, we derive the design of the T-shaped antenna and the performance analysis are checked where the return loss are estimated by varying the frequency. Let me discuss about the running procedure for our process. Select the main.m file in the current folder, right-click the file and run for executing this process. Here I initialize the parameter and in the MATLAB I derive the equations for estimating the impedance, resistance and reactive component for both vertical and horizontal slot. Here this derivation are performed for disk patch and square patch antenna. This process will execution. This will take more time for execution. After execution of this process, we obtain the result. This is the disk patch return loss result. By varying the frequency, we obtain the same return loss at every changes in the per frequency. And this is the square patch. Here at the 1.9 gigahertz we obtain the maximum return loss, and for 2.3 gigahertz we obtain the minimum return loss. Here we analyze the T-slot based both disk patch and square patch antenna. We derive the equation and performing the simulating results. Thank you.